So for the next lesson, I'm just going to talk about calculators and how this can help us, how calculators can help us with matrices. So essentially, we're not going to really learn anything new in this section. I'm just going to show you how you might use a calculator to pretty much do everything we've done over the last couple days. Now, the reason we don't just go straight to calculators when we're doing matrices is because I do want you all to understand how they actually work, because you need to build your intuition. If something does go wrong on the calculator, you need to know when that happens. You need to get good at identifying that. But in order to do most of the computations that we've talked about, calculators make things a lot quicker and easier, and make our lives a little bit simpler. So let's go ahead and start off by defining three matrices that we'll use for the first few examples, and then we'll see how the calculator can help us out. So let's go ahead and let's here we go. Let A be the matrix 1, -2, -3, 4, -5, 6. Really doesn't matter what I use here, although the order will matter. But if you want to follow along, use the same ones. And then, so we have two matrices that are 3 by 2s, and we'll do one more. This one will be a 2 by 3 matrix. Now I've noticed that some of you have been putting commas when you do this, so you might put commas in here. Those are unnecessary. You don't need to put any commas in. Some of you are forgetting to put the brackets on there. It doesn't really make sense if you just write down a list of numbers without those brackets, so please make sure you're using the correct notation when you do this. Okay, so let's go ahead and let's actually add 2 times A plus 5 times B. Now, regularly we'd have to distribute that 2 to each term in A and that 5 to each term in B and then add them. But let's go ahead and see what it looks like when we use our matrix calculator. So all I did here is I typed in Desmos, and I basically did a Google search for matrix calculator, and it shows up like this. Now I'm going to hit this button here that says new matrix. It's going to automatically give me a letter, which is A in this case. I want there to be 3 rows and 2 columns if you're taking a look back at our matrices here. So I'm going to go ahead and type those in, 1, and I'll use the arrow to go over, or you can click where you want to go. I like using these arrows here though, makes things a little bit easier for me. -2, -3, 4, -5, and 6, and I'm going to hit the return button, the enter button. Now I want another new matrix, and again it's just going to kind of go through A, B, C, and etc. So the next matrix I want was -2, 0. I need to have 3 rows. -2, 0, 3, -1, 10, and 5, and I'll hit return. So there's my second matrix. And then the third matrix, luckily they're using the same letters as us, although it doesn't really matter as long as we're careful. -4, 0, 3, -1, and 7. Okay, so here are my 3 matrices. Now, this does take a little bit of time to actually type in the matrices. That was kind of tedious to have to do. So you're not always going to want to use a calculator. If it's, takes less time to just go ahead and add them rather than using the calculator, keep that in mind. But right now I'm just showing you how you might use the calculator to do this. So what we wanted to do was just 2A plus 5B. So I'm going to write 2 times A, there's 2 times A, plus 5 times B, and there you go, I'm done. So I get -8, -4. Um, 9, 3, 40, and 37. I could probably do split screen here, but I'm just going to go ahead and write these down. And that would be my answer from the calculator. Okay, so pretty straightforward. And now that I've defined those matrices, I don't have to do that again. So if I wanted to now, let's say I wanted to do A times C, I could just write A times C, and there's my matrix. So that's actually very convenient. Instead of having to do all that workout, eight, 14, and then 42. Okay. There we go. Uh-oh, something weird happened. Yeah, so instead of having to write all the work, we can just easily solve for the matrix by typing it into the calculator. Similarly, if I wanted to do some other multiplication, I could try C times A. I get the 2 by 2 matrix. I could try out B times C if I wanted. I could do any combination I wanted of those. Okay, so that's the more basic stuff. That was adding and multiplying matrices. But what's nice is the calculator can actually do some other stuff as well. So let's go ahead, let's define a couple of new matrices here. I'm going to say, so new problem. I'm going to define a matrix A as 2, 1, 5, 3. We actually saw this one in a previous lesson. And I'm going to define B as the 3 by 3 matrix, 2, 0, negative 1. And then 0, 2. So what I would like to do now is I want to find A inverse. Now this wasn't too bad. We had the nice formula for it from a previous lesson, but if I want, I can just go over here. Now I do need to define a new matrix. So D is actually going to be my A in this case, 2, 1, 5, and then 3. And if you look over on the left-hand side where we have A, B, C, all those, if you look below there, you should see that to the power of negative 1. So if I hit D and then that negative 1, it'll actually give me D inverse. So that's how you get the inverse. It's kind of to the left of all the numbers there, in between the A squared and the A trace. Sorry, A to the power of T, which stands for A trace. You could even try that if you wanted. So you can try all these out if you'd like. But what I'm interested in here is D inverse. So 3, negative 1, negative 5, and 2 was A inverse. We could do the same for B inverse. But now I do have to define a new matrix, which we'll call E. It's going to be a 3 by 3. And this was 2, 0, negative 1, 3, negative 1, 1, and then 0, 2, negative 3. So there's E. Go ahead and find E inverse. And there is our E inverse. We could rewrite it as a fraction if we wanted, if we click on that button next to the matrix. Up to you. And so we could actually find E inverse from this as well. I don't know if I necessarily want to write all this out. I'll go ahead and write it out. So we have B inverse is negative 1/4, 1/2, positive 1/4. I have this written down from the previous lesson, so that's what I'm using. I think that's right. I'll just do a quick check. Yeah, looks good. Okay, so we got both of those using the calculator. So the calculator can do basic operations, add, subtract, and multiply. It can also do inverse. It can even do determinants. So let's say I wanted to find the determinant of A. Well, I would just go over to my calculator here, and underneath inverse, conveniently, it says det. I can hit det. Now, actually, I defined the matrix that we've been using as D, so I need to use D here. But there you go. The determinant of D is just 1, and in this case, that's matrix A. Or if I wanted to find the determinant of B, could use det. Now I've been using E on the calculator. So that would be -4 in this case. So it saves us quite a bit of trouble to do this, and it also allows us to do much larger matrices. Instead of having to restrict ourselves to 2x2s, 3x3s, we can actually go even larger, and it becomes a pretty straightforward process of finding inverses and determinants. The hardest part really is just plugging it in correctly. Okay, so that's all just calculator stuff that kind of summarizes the last couple days, what we can do pretty quickly from the last couple days. But what I'd like to do next is give you something new. So something that's kind of going to be a cool application of matrices here. So we're going to talk about something called row echelon form. And specifically, we're actually going to talk about reduced row echelon form. So it was discovered some time ago that matrices kind of work the same as systems of equations, or they can. So for example, let's start with an example here, and then I'll sort of explain more about what all this stuff means. Let's say I wanted to solve the system 3x plus 2y equals -7 and -2x minus 9y equals 3. So you all know how to solve this. You have to use elimination or substitution, and you could figure out an x and you can figure out a y. But it was discovered that we could use something called an augmented matrix. And just use the coefficients, 3, 2, and then -7, -2, -9, and then +3. It's called augmented because it's a square matrix, technically, with another 2x1 matrix next to it. So it's sort of two matrices, and they've been combined or augmented. The square matrix has been augmented by the other one. And it was realized that if you do something called elementary row operations to this, which we're not going to get into, but essentially you can add and subtract rows, you can move them around, you can do all this stuff. You're changing the matrix, but it does help you solve the system of equation. And the final form is called reduced row echelon form. Now, if you want, we can talk more about this in class if any of you are interested in it, which I'm happy to do. But in terms of just the application, I'm going to skip all of that stuff, and I'm going to have us actually solve this using the calculator. So we're going to go ahead and solve that system using reduced row echelon form, which is RREF on the calculator, of the matrix A, where A is the augmented matrix 3, 2, -7, and then -2, -9, and 3. So here's what we're going to do. Let's go to our calculator here. I'm going to go ahead and just clear everything. Above the divide symbol, you should see that clear button. So I'm going to click that. I'm going to do a new matrix. It's going to be 2 rows and 3 columns. So I'm going to go 3, 2, -7. And then we're going to look at, the next row is -2, -9, and 3. Now, underneath the a squared, all the way in the bottom left corner, you should see RREF. I'm going to do that for A. And there is my solution. So let me talk about what this means. So let's go ahead and first write this. So RREF of A gives me the matrix 1, 0, 0, 1. And then I have the fractions negative 57/23 and positive 5/23. So what this means is, going back to the original equation, this just means if I were to write this system as equations now, I would have 1x plus 0y equals negative 57/23. And then 0x plus 1y equals 5/23. Whoops, I keep doing that. So technically, what I've just done is I've actually solved the system. X equals negative 57/23, and y equals 5/23. And so that would be my solution. You could go back and check that if you'd like, or you can take my word for it that that's actually an answer. So when you solve systems of equations, this is a much better way to do it than having to actually go through the process of adding, subtracting, substituting, anything you want like that. This is a really slick system for that. And what's nice is it solves larger systems as well. So back in section 7.3, I think it was, we were solving systems of 3 equations. And it got kind of difficult because it was hard to keep track of all of our work. We had to eliminate, we had to substitute, we had to do all these different things, and it was sort of annoying to keep track of everything that was going on. So let's go ahead and see what this looks like in matrix form. Okay, so the first thing I'm going to do is construct my augmented matrix. Coefficient of x is 1, y is 1, negative z is negative 1, and then I have a 4. Next row is going to be 1, negative 2, 3, negative 6, and then 2, 3, 1, and 7. So remember, I'm just taking the coefficients, so I'm taking the 1 and the 1, and then the negative 1. 1, negative 2, 3, 2, 3, 1, and then 4, 6, whoops, negative 6, and positive 7. That's how I get my numbers. So we'll go ahead, let's just call this matrix A. And so then I need to do the reduced row echelon form of A. So let's go ahead and clear everything. Define a new matrix. It's going to be 3 rows and 4 columns now. So again, this is kind of the hardest part, is making sure you type everything in correctly. So bear with me while I do that. Sing a song if you like. Fast forward to the end, but don't give it away. So there's A, and now the calculator is going to solve this equation for us, this system of equations. 1, 2, negative 1 is the answer. So that tells me that x is 1, y is 2, and z is negative 1. So this is a super powerful tool. I hope you are coming to realize there's a lot we can do with with matrices, and the calculator helps speed that up quite a bit, which makes it pretty cool. So that's going to actually conclude this lesson. There's nothing really new here, but I am going to have a Delta Math posted, and I'd like you guys to do all the Delta Math problems, but try to do it on the calculator. Additionally, if you don't like using this Desmos calculator, that's fine. The other common calculator that you might have is a TI-84 or 83. I would recommend just doing a Google search for TI-84 calculator matrices, and it'll give you a lot of tutorials on how to do that. There's even one in the middle here using them to solve systems of equations. So a lot of helpful techniques here. They're not super long videos, or you can just use that Desmos matrix calculator.